Imagine like getting hit with just crippling ransomware. The kind of attack where every single screen in your organization suddenly goes red, files are completely locked, and that ransom demand just pops up.
Yeah, which is pretty much the absolute nightmare scenario for anyone in IT.
Right. And normally that kicks off a massive company-wide panic. You're looking at millions of dollars in downtime and, weeks of IT teams just scrambling in the server room, completely stressed out.
Oh, absolutely. It's chaos.
But instead of panicking, imagine you just go get a cup of coffee, and 30 minutes later you sit back down and your computer has completely rebuilt itself from the inside out. Like factory fresh, with all your files exactly where you left them.
I mean, it sounds like science fiction, right? Or at
Oh,
least, some kind of luxury for a Fortune 500 company.
totally.
But the reality of the modern threat landscape is actually turning that kind of autonomous recovery into an absolute baseline necessity.
And that is exactly what we are exploring in this deep dive. Whether you're, sitting there prepping to secure your own team's network, or you're just intensely curious about what goes on behind the screens in these invisible digital conflicts, this is custom tailored for you. We are
Mhm.
looking at this massive collision of three forces today. We've got the sheer terrifying speed of AI-powered cyber attacks, the shocking lag of institutional defense, and then these fully automated recovery systems that are stepping in to act as basically the last line of defense.
Right. And we're pulling from a really specific stack of materials today to map all of this out.
Yeah, tell them what we've got.
So we have threat intelligence reports detailing state-linked AI cyber tools, a highly critical federal audit on U.S. aviation cybersecurity, and the technical documentation on a zero-touch endpoint recovery platform called Swimmage.
Now, regarding those threat reports, we are pulling data from groups like Recorded Future, Group IB, and Checkpoint Software. And they're tracking state nexus actors from places like Iran and China. And just to be super clear right up front, we are looking purely at the ones and zeros here. We are not here to debate geopolitics or, take any sides regarding state nexus actors.
Exactly. We only care about the technological mechanics of the malware and the tactics that are detailed in the source material.
Spot on. So, diving into those tactics, what are these threat actors actually doing with AI?
Well, what's fascinating here is that when we look purely at the tools, we aren't seeing fully autonomous Terminator-style AI models launching attacks entirely on their own.
Right. The AI is not the hacker itself.
Exactly.
Yeah.
Rather, these threat actors are using large language models, or LLMs, to compress the distance between intent and action. It's basically a massive accelerator.
Okay, let's unpack this.
Yeah.
Because it's like they aren't inventing an entirely new sport, right? They just gave their existing players rocket-powered running shoes.
I love that analogy. Yeah.
The playbook hasn't necessarily changed, but the execution is just radically faster.
That speed completely alters the threat equation. Take a classic tactic, like phishing. Historically, if an attacker wanted to launch a highly convincing social engineering campaign in a language they didn't speak natively, you could usually spot it, right?
Yeah, for sure. The grammar was usually slightly off, or, the cultural idioms were just wrong.
Right, exactly. But today, they leverage LLMs to sustain these deep, complex, multi-day email threads in languages they don't even know. And the phrasing is flawless.
Wow. And it goes way beyond just writing convincing emails, doesn't it?
Oh, absolutely.
Yeah.
The reports highlight how these groups use AI for reconnaissance on highly complex industrial systems.
Right, because if you're a hacker trying to break into, say, a proprietary piece of manufacturing infrastructure, you normally have to spend 6 months learning how that specific software works.
Yeah, you have to read the manuals, understand the architecture. It takes forever.
But now you can just feed the technical documentation into an LLM and literally just ask it to highlight the architectural weak points.
Which drastically lowers the barrier to entry for these highly specialized attacks.
It's what?
And we see this acceleration playing out in the real world with a group tracked as Muddy Water.
Oh, right, the Olalampo operation?
Exactly. In Operation Olanam, targeting organizations across the Middle East and North Africa, they used AI to develop 4 distinct malware variants delivered through malicious Office documents.
And they did all of that within a single January campaign.
Yeah.
4 custom variants in a month. I mean, if you are relying on traditional antivirus software, the kind that just looks for known bad code signatures, you are dead in the water.
Completely. Because by the time your security vendor flags variant 1, the attackers have already used AI to rewrite the code into variant 3.
It's like playing whack-a-mole, but the mole moves at the speed of light.
That's exactly what it is. And then you have a group called Ababil of Manab. They used ChatGPT in an attack against a U.S.-based GPS tracking firm called Vinx.
Okay.
But they didn't just ask the AI to, hack the system. They used it to refine a highly specific script designed to enumerate and drop databases.
I really want to highlight why that specific detail is a total game changer for the listener.
Yeah, go ahead.
Normally, once an attacker breaches a network, they have to spend weeks manually poking around complex databases, right? Just trying to figure out where the valuable data is actually stored.
Right, the discovery phase takes time.
But with ChatGPT acting as basically a coding co-pilot, the AI can read the database architecture in seconds and write a custom extraction script instantly.
Yeah.
It turns this painstaking week-long heist into a smash and grab that takes like 3 seconds.
And that same group, incidentally, later claimed credit for a breach of the Los Angeles public transit system.
Jeez.
So the scale of this AI usage is getting so intense that it's forcing the AI developers themselves to respond.
Right, the sources mentioned OpenAI had to step in.
They did. OpenAI had to step in and shut down accounts linked to a group called Charming Kitten and another one called Cyber Av3gers.
Cyber Av3gers, yeah.
That second group was actually using ChatGPT to conduct reconnaissance on programmable logic controllers, or PLCs.
Okay, just for context for you listening, PLCs are the digital brains that control physical machinery. They are the actual computers that tell a water valve to open at a treatment plant or, tell a centrifuge to spin in a lab.
Exactly.
So if you are using AI to figure out how to compromise PLCs, you are bridging the gap from the digital world straight into physical destruction.
Which is why OpenAI intervening is significant, sure. But it's ultimately like trying to build a firewall out of sand while the tide is coming.
Yeah, it's just not going to hold.
Right. And this raises an important question about how these threat groups bypass restrictions. Because of internal infrastructure limitations in Iran, they can't easily build massive frontier AI models of their own.
So they have to look elsewhere.
Exactly. Threat analysts project they will increasingly lean on strategic alliances, utilizing Chinese frontier models like one called Claude Code to basically keep their rocket shoes strapped on.
Okay, so if the attackers are moving at that kind of accelerated AI-driven pace, how is our critical infrastructure responding? Because this brings us to a really alarming case study in our sources, which is the U.S. aviation sector.
Yeah, the contrast here is genuinely stark. We're looking at a recent audit from the Government Accountability Office, the GAO, which reviewed the cybersecurity oversight provided by the Federal Aviation Administration, the FAA, and the Transportation Security Administration, the TSA.
And the findings, they point to deep systemic vulnerabilities.
Oh, absolutely.
I have to pause on one detail that is just staggering to me. The audit found that TSA is relying on a cybersecurity roadmap from 2018. Wait, in the cyber world, 2018 is basically the Stone Age. How can you defend against 2026 AI threats with a map drawn 8 years ago?
The short answer is you struggle immensely. And the aviation sector's threat landscape reflects that struggle perfectly.
The incident numbers were crazy.
Yeah, the volume of incidents reported to the Cybersecurity and Infrastructure Security Agency is erratic, but it is consistently high. We saw incidents spike from 290 in 2020 to 562 in 2022. It dipped temporarily, but the projections show it climbing right back up to 352 in 2025.
I gotta say, hearing those numbers while thinking about sitting in a metal tube flying at 30,000 feet is honestly terrifying.
Right, I get that. But let me offer a very important caveat to those numbers because precision really matters here.
Okay, fair enough.
There have been 0 reported successful cyber attacks on aircraft avionics.
So the planes themselves are okay?
Exactly. The actual flight control systems remain secure. The vulnerabilities the GAO is flagging exist within the broader ground-based networks.
Right, okay. We're talking about operational technology, or OT.
Yes.
This is the digital infrastructure running the physical environment of an airport, like the baggage handling belts, the runway lighting, the HVAC systems, the air traffic control communication relays.
Exactly. And the vulnerabilities within that operational technology aren't necessarily advanced zero-day exploits.
Which are those rare, unpatched flaws that software creators don't even know exist yet, right?
Right. They aren't using those.
Yeah.
The GAO found failures in basic digital hygiene.
Really? Like what?
We are talking about unsupported operating systems, operational networks left completely accessible to the public internet,
Oh, man.
and default credentials. Like systems where the password is quite literally still left his password.
That is, I mean, that kind of basic hygiene failure usually points to a massive breakdown in leadership. Because if no one knows who is supposed to enforce the rules just don't get enforced.
Exactly. And the audit found the TSA, which oversees security programs for airports, hadn't even clearly assigned which of its own internal offices was responsible for cyber oversight.
That is wild. And that internal lack of clarity bled out into massive industry confusion, didn't it?
It did. In March 2023, and the TSA issued a joint emergency amendment requiring aviation operators to lock down their systems.
Makes sense on paper.
Sure, but industry representatives pushed back, genuinely confused because they believe cybersecurity fell under the FAA's authority, not the TSA's. You know, one airline frankly told the GAO they didn't believe the TSA even had the technical expertise to regulate cyber networks at all.
It created a total jurisdictional nightmare.
Completely.
It actually required an act of Congress, the FAA Reauthorization Act of 2024, to step in and grant the FAA exclusive authority over civil aircraft cybersecurity, literally just to figure out who was legally allowed to give orders.
Right. But granting the FAA authority doesn't solve the technical debt.
Yeah.
If we connect this to the bigger picture, the FAA is actively failing to secure its own internal environment. They're really struggling to transition to a zero-trust architecture.
Okay, and zero trust being the security framework that, abandons the old idea of a trusted internal network. You don't just assume a user or device is safe simply because they are inside the building or on the VPN. In a zero trust model, every single device and every single application has to cryptographically verify its authorization every single time it tries to communicate.
Perfectly said. And achieving that requires adhering to 7 key migration practices laid out by the National Institute of Standards and Technology.
And how did the FAA do on those?
The GAO found the FAA fully addressed only 3 of them.
Only 3 out of 7.
Yeah. Crucially, they completely failed to implement detailed transition plans for their research and development environments.
Wait, the R&D environments?
Yes.
But that is where the entire future modernization of the national airspace is being built.
Exactly.
If your R&D servers aren't locked down with zero trust, you are designing the next generation of flight software on a fundamentally compromised foundation.
It's a huge problem. And the structural issues even extend to their budget reporting. The FAA somehow failed to report millions in cybersecurity spending to the Office of Management and Budget.
How do you just lose track of millions of dollars?
Well, we are looking at a blind spot of $6.4 million missing from the reporting in 2024, $5.9 million in 2025, and $4.6 million in 2026.
That's wild.
And if the government entities allocating funds don't even have an accurate ledger of what you are spending, they cannot make informed decisions about funding the AI defenses you desperately need.
It's definitely not a great look, but it's not entirely bleak, though, right?
No.
The report did note one significant silver lining. When the FAA and the TSA are forced to sit at the same table via the Aviation Cyber Initiative, they actually collaborate very effectively.
Yes, they met all 8 of the GAO's best practices for interagency collaboration.
Okay, so the human collaboration is there.
It is. The problem is the architectural foundation they are trying to protect is outdated, and the roadmap is obsolete.
Right. And if an institution with the resources of the FAA proves that building an impenetrable wall is bureaucratically and technically impossible, everyday organizations have to operate under a harsh new reality. You have to assume the attackers with their AI-accelerated malware are going to breach your perimeter. It is a matter of when, not if.
Exactly. And when you accept that the perimeter will fall, the only metric that actually matters is resilience.
Right.
How fast can you survive the hit, contain the damage, and rebuild?
Which brings us to the technological safety net in our sources today, these automated zero-touch recovery platforms.
Yeah.
Specifically, we're diving into the technical documentation for a platform called Swimmage.
So Swimmage operates as a fully automated incident response mechanism. If an endpoint, say, an employee's laptop is corrupted by malware or entirely locked down by ransomware, this tool can completely rebuild the operating system.
Automatically.
Automatically, zero touch, in under 30 minutes, sometimes even under 15.
Okay, here's where it gets really interesting.
Yeah.
Because we have to talk about the offline deployment capability.
Oh, this is the best part.
If a computer gets hit with ransomware, the standard protocol is just panic, right?
Usually. Yeah.
Someone unplugs the Ethernet cable to stop the infection from spreading across the network, and then that machine is just dead weight.
It's useless.
Right. A human IT worker has to physically walk over with a clean USB drive, wipe the hard drive, and manually reinstall Windows.
Which takes hours.
But Swimage can rebuild that machine even if it is completely severed from the network.
It achieves that because it doesn't rely on pulling a fresh operating system image from a cloud server.
Okay, so where does it get the files?
All the necessary installation files, the security policies, and the configuration settings are stored locally on the machine. They're in a hidden, highly secure partition on the hard drive that the ransomware literally cannot access or encrypt.
It's like a submarine taking on water.
Yeah.
Instead of waiting for a rescue ship to plug in a pump from the outside, the submarine just automatically seals the bulkheads, isolates the flooded compartment, and pumps the water out from the inside entirely on its own.
That is exactly how it works. And that isolated rebuild process perfectly executes the zero trust framework we just discussed with the FAA.
Right.
It forces the endpoint to prove it is mathematically clean before it ever requests an IP address to rejoin the corporate network.
The documentation breaks this down into the 4 formal stages of incident response, and seeing how automation handles them is just wild. Stage 1 is preparation. The software essentially memorizes what normal looks like for that specific machine, establishing baseline health metrics.
And then stage 2 is detection and analysis. The moment anomalous activity occurs, like, say, a script rapidly trying to encrypt files, it instantly locks down the endpoint.
Boom, sealed off.
Sealed off.
Okay.
But before it shuts down, it actually captures an image of the system's volatile memory, the RAM.
Oh, wow. That is massive for forensic analysis.
It's huge.
Because usually when you reboot a compromised computer, the RAM is just wiped and the attacker's footprint disappears. Capturing that memory means you preserve the evidence of exactly how the AI malware got in.
Right, you don't lose the crime scene.
Oh.
And then you move to stage 3, which is containment, eradication, and recovery.
The submarine sealing its doors.
Exactly. The system isolates itself, it automatically scrambles all local administrator passwords so the hacker is locked out, and then boots into that hidden partition we talked about.
Okay.
From there, it completely overwrites the infected operating system from the inside out.
It just paves over it.
Yep. It eliminates rootkits, which are those nasty viruses that bury themselves deep enough to literally lie to your antivirus software, and installs fresh, clean code.
But wait, if it wipes the drive to kill the malware, what happens to the user's files? Because, I mean, if I get hit by ransomware, I don't just care about getting Windows back. I care about my spreadsheets and my local data.
And that is the crucial differentiator here. During this rebuild process, the system utilizes a proprietary method to securely ring-fence, scan, and back up the user's data and profiles.
Okay, so it protects the data while it wipes the OS.
Exactly. So when the machine comes back to life 30 minutes later, not only is the OS factory fresh and patched, but all the user's data is restored exactly where they left it.
That is incredible. I mean, think about your own organization's IT department for a second. Turning a catastrophic ransomware event, which usually requires a forensic team and a week of downtime, into an automated 30-minute coffee break completely alters the economics of a cyber attack.
It really does. And the documentation also highlights a tool called the Swimage Encryption Converter.
Oh, yeah, I saw that.
Migrating a massive fleet of PCs from one type of hard drive encryption to another is usually just a total nightmare of decrypting, moving data off the machine, and re-encrypting.
Yeah, nobody wants to do that.
But this tool passes the cryptographic keys securely within the system's memory, converting the encryption on the fly without the data ever leaving the drive.
So it maintains an unbroken chain of trust.
Exactly.
And the real-world applications of this leverage are pretty staggering. In the source material, we're looking at a case study where a chief technology officer for a federal government agency used this automated approach to replace and secure nearly 5,000 PCs in just 3 months.
5,000 in 3 months. And for smaller organizations, the force multiplication is even more apparent.
Oh, yeah, the nonprofit example.
Right. An IT director for a national nonprofit reported utilizing this zero-touch deployment to rebuild 60 computers across their network in 2 hours.
2 hours.
2 hours. And it only required one single person to oversee the dashboard.
It fundamentally shifts the paradigm. If you can heal yourself faster than the attacker can damage you, the attacker's speed advantage is completely neutralized.
Right. It is basically the only viable defense when the adversary is iterating malware at the speed of thought.
Well, we have covered a massive spectrum of the digital battlefield today.
We really have.
We started with state nexus threat groups utilizing large language models to, shatter language barriers and write custom database extraction scripts in seconds.
Mhm.
We navigated through the bureaucratic maze of the FAA and TSA, exposing the dangers of relying on outdated roadmaps and failing to implement zero trust in critical R&D networks.
Yeah, that 2018 roadmap.
Right. And finally, we looked at how automated offline recovery systems act as the ultimate failsafe, basically turning crippling breaches into minor, self-healing inconveniences.
We're looking at a complete snapshot of modern conflict here. The technological capabilities at the very edges, both offensive and defensive, are evolving exponentially, while the human institutions caught in the middle are just really struggling to keep up.
So, what does this all mean? When you look at the trajectory of these sources, it paints a very specific picture of where we are heading, and it leaves me with a lingering thought that I want to pose to you.
Okay, I'm listening.
Yeah.
Because the escalation toward total automation on both sides of the perimeter feels pretty unavoidable.
Exactly. If attackers are increasingly utilizing AI to generate and execute complex network breaches in seconds, and our defensive recovery systems are becoming fully automated, zero-touch, and capable of isolating and rebuilding a machine in minutes,
Yeah.
are we rapidly approaching a threshold where human IT professionals and human hackers are entirely removed from the equation?
Oh, wow.
Will the future of cyber warfare just be an AI attacker fighting an AI defender in a closed, invisible, milliseconds-long loop, while we simply sit at our desks drinking our coffee, completely unaware that a digital war was just fought, lost, and won right inside our hard drive?
It is a profound possibility. I mean, the timeline of the battlefield is shrinking down to a scale that human perception simply cannot track.
It's an intense reality to consider. Thank you for joining us on this deep dive into the architecture of modern cyber warfare. Keep questioning the security of the systems you rely on, keep an eye out for those invisible battlefields, and we'll catch you on the next one.